All right, in this section, what we're going to do is look at parent graphs and families of graphs and do some transformations with them. This truly is a review from Algebra 2. We are going to add in one piece this year, though. So what I'm going to do is just really quickly go through and remind you what some of our parent graphs are. You may have to pause this along the way just to write down some of the information in terms of maybe your tables and your graphs and some of that, because I don't want to spend a whole lot of time on that. It should be somewhere in your notes already. When we graph linear functions, we really don't use a parent graph. We're very good at already dealing with it if it's in slope-intercept form or if it's in standard form, using our intercepts method to get a pair of points and connect those. So I don't even talk about the table with a linear function, but your parent graph for a linear function would be y equals just x. Okay. With our quadratic, again, that's the idea of when I graph it, I get a parabola. And the table that we use in general are these values that we will end up transforming. So the -2, when I square it, becomes a positive, obviously, and so on and so forth. So like I said, if you need to copy that down, just go ahead and pause, and then we'll jump up to the next one. X cubed, that's our cubic function. Okay, our values that we use there is when I plug in -2. Okay, I'm going to take negative times negative times negative to get that -2 times 2 times 2 to get -8. Okay, so remember that. So there's our table. And the thing we have to be careful of is when I deal with y equals the cube root of x. Now, it's not included in this section, but I'm going to draw it up here quick. What happens is a lot of times if we only use those middle 3 points, we can get confused. Okay, because when we go in here and look at the table for the cube root of x, I have those same 3 points in the middle. So that's why we got to use 5 points. Because what happens is now when I take the cube root of -8, it becomes -2. When I take the cube root of +8, it becomes 2. And so what happens is our graph will look very similar, but now it's laying down on its side. Okay, so that'll be one we're going to use when we get into our inverses and a couple other things, so it might not be bad to actually add that into your notes. Square root of x, again, remember with the negatives, what we get are imaginary numbers, and so we're not going to include those because we don't graph imaginary numbers. And that's why, again, chapter 1, we talked about domains being greater than or equal to 0. But we'll use 0, 0, 1, 1. Then we skip 2 and 3 because they're not perfect squares, but I'm going to use 4 and 9. Because they are perfect squares, easier numbers to deal with when we're plotting points when we're transforming. Absolute value, again, we dealt with that in chapter 1. So there are other methods of graphing our absolute value than looking at the table of values, but if you need to, you can always jump back to those. With your rational function, remember we have those asymptotes because x can't be 0 because we don't want to divide by 0, or we can't divide by 0. We have the horizontal asymptote y equals 0 because the only way a fraction can be equal to 0 is if my numerator is 0 and it's already been defined to be 1. So the points I'll use here is I'm going to use generally -2, -1, -1/2, and then just flop those, +1/2, 1, and 2. Okay, because when I take 1 over, okay, this becomes -1/2, this becomes -1, this becomes -2. Notice how they just kind of flipped with each other. So this becomes 2, this becomes 1, this becomes 1/2. Okay, and kind of can be handy when we have it that easy. Greatest integer function. You know, really, if you can remember this one right here, you should be in pretty good shape. Okay, and again, we talked about how we can just move that one around, and we'll see what happens with our shrinks and stretches here eventually. But again, the thing to remember is if I plug in an integer into my greatest integer function, it kicks that integer out. Okay, whereas if I kick in a fraction or a decimal, I always want to go down to the next lowest integer if I need. All right, this also now is some review. When we talk about I can transform my function by doing a number of things, A, B, C, and D. A and D, okay, they are things that we do to my function. So it's something that I'll take an x squared. I can multiply my x squared by a value for A, so 2x squared. I can take x squared plus 4. Okay, those things, again, affect us in a vertical fashion. And when we change vertically, we're changing our y values, okay, if I'm using that table. And again, a vertical stretch happens when the number piece of A, so the absolute value of A, is bigger than 1. A shrink happens when that number piece, so the absolute value of A, is between 0 and 1. Now the negative just means we're going to reflect it over the x-axis. Now when we get into our describing, since we just dealt with symmetry, you have to remember there's a number of lines that we can reflect over. And so now you have to be specific in terms of what line am I reflecting over. Okay. And again, our D is just going to move us up or down. So none of that is new. Okay. Now, we do get to the horizontal part now on the inside. Anytime we're on the inside, again, that affects us horizontally. And a couple things with that again. When we deal with horizontal, it changes my x. And what we want to do is always do the opposite. Okay, so if it's a plus, we want to do a minus. If it's a times, we're going to do a divide. Okay, so C, again, is going to move you left to right. You've done that plenty of times. Okay, if it's a plus C, we're moving left. If it's a minus C, we're moving right. What's new now is we're going to deal with the B value. Okay, and think about opposite. Okay, so when we reflected over the x-axis, it was because A was less than 0. So when B is less than 0, we're going to reflect over the opposite axis. We're going to reflect over the y-axis. Okay. A horizontal stretch. Okay. A horizontal stretch. Well, a stretch vertically was when the number piece was greater than 1. So now it's going to be when that number piece, the absolute value of B, is between 0 and 1. So again, we want to do the opposite. Same idea with the shrink. Okay, a shrink vertically was when it was between 0 and 1, but a shrink now is going to be when that value, the number part, is greater than 1. Okay. Now, for this to work out nicely for us, what we always want to do is factor the coefficient of x out. Okay, I want to have it so I have B, and then in parentheses, my quantity, x plus C. Okay, that's how we're going to change that. Okay, that's going to be the new piece. So when we look at an example, okay, number 1, we have to figure out what is my parent graph. And so what I see is I'm dealing with something to the 3rd power. Okay, and why I need to deal with that again is so I have my points from my parent graph, and I can put those onto my grid, onto my coordinate plane, and kind of sketch out what it looks like. Okay, because what I want to do again is talk about these transformations beforehand. So when I graph it, I can see, did they actually happen? So now, like I mentioned, what we want to do first is take this 3 and factor it out, because I want 1x plus or minus something to determine left and right. Okay. I don't want 3x plus or minus something. I need 1x plus or minus something. Okay. So when I talk about describing my transformation, that 2 is going to move you to the right 2. This 3, well, again, thinking opposite. When it was vertical, that was a stretch. So now, it'll be a horizontal shrink. Okay. So again, start with your parent points, points from your parent graph, and now we can deal with our transformations. Now I haven't changed my y at all. Okay, so I'm just going to go in here and change my x values. Okay, follow your order of operations. So I'm going to start out with the horizontal shrink. Now again, remember, we're doing the opposite. I'm going to divide by 3. Okay, so I'm going to take negative 2 divided by 3, negative 1 divided by 3. 0 divided by 3, 1 divided by 3, 2 divided by 3. Okay. Now I'm going to move it to the right 2, so that's where I'm going to go in and add 2. So if I add 2 here, I get 1 1/3, 1 2/3, 2. 2 1/3, sorry, 2 2/3. Okay. And go plot my new points. Okay. At 1 1/3, we're down here at negative 8. Okay. At 1 2/3, we're at negative 1. 2, 0, 2 1/3, 1, and then up here at 8. And it got really, really skinny, and sometimes those are tough to kind of sketch. You may need to just change your scale on your coordinate plane and maybe go up by 1/3, and you'll be able to see a little better. But now you can see that I did in fact move it to the right too, like I said, and it did shrink horizontally. Now, notice that horizontal shrink looks just like a vertical stretch. And with a lot of the functions we're going to deal with now, that's going to be true. Okay. When the horizontal shrink and stretch will really come in effect will be when we start dealing with our trig stuff. All right, so let's look at one where we do a bunch of transformations. So let's say we're going to take y equals -2, and let's go 4x plus 8 minus 3. Okay. And if I'm going to graph that one, again, same idea. Actually, I want squared, didn't I? Same idea. Number one, I want to start out with my parent graph. Y equals x squared. Okay. I'm going to think about my table of values. And then I'm going to describe my transformations. Now, I'm going to do one at a time. I'm going to start out with my x's, so I'm going to deal with all these first. Okay. Again, I want to factor the 4 out because I want to know what I'm adding or subtracting to x. Okay. So what I have, that 4 tells me I'm going to have a horizontal, not stretch, a shrink this time. And that 2 is taking it to the left 2. Okay. So I'm going to go in and change my x's first. Okay. I'm going to divide by 4. Again, we're doing the opposite. And then I'm going to move it left 2. So I'm going to subtract 2. All right, now I'm going to deal with my y stuff. Okay. Out here, we're going to reflect. And again, what are we reflecting? X-axis. Okay. And I'm also going to have a vertical stretch. Minus 3 is going to move you down 3. Okay. So multiply everything by -2. Okay. Subtract 3. Okay. Now all right, let's plot these points. So what I'm going to do is I'm going to rescale my axes since my x's are going up by quarters. So here we have -1/4, -1/2, -3/4. So there's my -1. Here's going to be my -2. Okay. So if I plot my points, -2.5 is going to be down here at -11. Okay, so we'll just estimate about where it is. -2.25 is going to be down here at -5. -2 is going to be at -3. And then we're just coming back with our symmetry idea. Now you can sketch your parabola and be done. Okay. All right, my advice also now today, it would be to go in, especially on ones where you have horizontal stretches and shrinks, to go and put them on your graphing calculator to make sure that they do match up with what you've done by hand. Okay, so I've done that with fooplot here, and so what you can see is that at -2, I am in fact at about -3. At -2.5, I am at about -11 where it's supposed to be. It'll be easier to do with your graphing calculator because you'd be able to actually go to your table of values. All right, good luck with this assignment.